The notes we're going to take today are about quantitative relationships. In other words, the quantity you start with determines how much you produce. In an industry, this is really, really important because it's your product, it's what you sell. And there's another name for this is called stoichiometry. And it's the relationship between your reactants, what you start with, and your products, what you make. Okay. One thing to remember about doing these problems is if you don't have a balanced equation, you cannot do them. Because if you look at a balanced equation, here's a simple one, 2H2 plus O2 yields 2H2O. These numbers represent moles. So we have 2 moles of hydrogen to every 1 mole of oxygen to every 2 moles of water. Okay? We use those when we're trying to figure out relationships between reactants and products. Okay? So if you look here, it talks about the coefficients. Those are the numbers. Those actually represent the moles of the reactant and the product. So it's really important whenever you do these. If you don't have a balanced equation, you cannot do stoichiometry problems. And again, stoichiometry problems looks at the relationship between what you start with and what you end with. They can be one step, converting from moles of one thing to moles of another. That's where you use your balanced equation. They can be 2 steps. If you start with moles, you can convert it to grams. And we did that before, okay? The longest ones and probably the ones that you use the most are grams to grams because that's the easiest thing for us to measure. We don't have mole meters, so we can't measure out moles, but we certainly can measure out grams on a scale. So those are the ones that are 3 steps, but those are the ones that honestly make the most sense to use. Here's an example of a simple reaction, sodium and chlorine, and you end up with sodium chloride. In here, I know that I have 2 moles of sodium for every 2 moles of sodium chloride. I have 2 moles of sodium for every 1 mole of chlorine. I have 1 mole chlorine for every 2 moles of sodium chloride. So those all come into play when we start looking at doing stoichiometry reactions. Okay, so it's really important that you have a balanced equation. Okay, when you're doing a stoichiometry calculation, if you start with grams of A, you can't do anything with it until you change it to moles. And that's like we did before. Okay, if I'm trying to change, I have 25 grams of water and I'm trying to change it to moles, I'm just going to put 1 mole on top and the formula mass of water on bottom, 18. And then I just divide and then I'd have my moles. So if you start with grams, you got to change it to moles. Okay, once you get your starting steps, the stuff you're going to start with, into moles, then you do what they call a mole ratio. It comes right from your balanced equation. You put moles of what you start with on the bottom, moles of what you're trying to find on top. Okay, this is the only time you use your balanced equation. It's important to remember that. And then if it just asks for moles, you're done. If it wants it back into grams, then you do the reverse of this. Now you take your moles and you change it into grams. So you're going to multiply by its formula mass. Here I divided, here I multiplied it. But these are 2 different substances. And again, I'm going to show you because this might not make sense yet, but I'll show you how it works, okay? Here starting with 1 gram of C6H12O6, that's glucose. Okay, I can't figure out right into water. I got to go through these steps. So if I'm going to change this, here we're going to figure out we're going to calculate the moles of glucose first. So we're going to take 1 gram and we're going to multiply 1 mole on top and 180, excuse me, that's the mass of it. Gives you the moles. It's a small number because if you think about it, if it's 180 and you only need 1 gram, that's a pretty small number. Then I do my mole ratio. I put what I'm trying to get rid of, glucose on the bottom, and what I'm trying to find, in this case water on top. This 6 comes from here and this 1 comes from here. So those are where you use your coefficients and then you can convert it. But I'll show you a better problem. That one might still get a little confusing. This is better. Okay, so in space, when you breathe out carbon dioxide. Well, what they have is devised a way to absorb that, because if you get too much carbon dioxide, you're going to die because you're not supposed to breathe in a lot of carbon dioxide. It won't hurt you unless that's all you have to breathe. You still need your oxygen. So what they do is they send up lithium hydroxide. It absorbs carbon dioxide. Okay. So what happens is they got to calculate how much you need to send up. They'll calculate how much carbon dioxide you breathe out, and then they'll send it. Some people will say, well, just send a whole bunch of it. Well, that's not really going to work because if you send too much, then it's more weight, and then you got to leave other things behind. Okay? So what you do is you've got 1 gram of lithium hydroxide. Okay, I'm going to change lithium hydroxide from grams to moles. So I put 24 grams on the bottom. Oh, shoo, I didn't have my balanced equation there. Sorry, guys. I'm going to put 24 grams on the bottom because that's what 1 lithium, 1 oxygen, and 1 hydrogen weigh. That's its formula mass, the number you'd get from your app on your phone, in 1 mole. Okay, so now what I've done is I got rid of grams of lithium hydroxide and I got moles. This comes from my balanced equation. Okay, I'm trying to get rid of moles of lithium hydroxide and I'm trying to find carbon dioxide. So if I look up here, I put a 2 here and I put a 1 here. Okay, that's the same as these coefficients that come from my balanced equation. Now I'm going to change 1 mole of carbon dioxide because I got rid of grams of LiOH, I got rid of moles, now I got moles of COH and I need grams. Okay, so I put 1 mole here and carbon dioxide has a mass of 44. That's 1 carbon and 2 oxygen added together. So I go 1 times 1 times 1, 44, divided by 24 divided by 2. And I get 0.92 grams of carbon dioxide. So what that tells me is for every 0.92 grams of carbon dioxide that I breathe out, I need 1 gram of lithium hydroxide. Okay, it'll take care of it for me so that I don't end up with, dying because I don't have enough. I have too much carbon dioxide, not enough oxygen. So in this case, it's kind of important because, if they don't send up the right stuff, you're going to be in trouble. But again, this is what they call a mass-to-mass relationship. What I start with, I change it to moles just by dividing by its formula mass. Then I do a mole ratio. This comes from my balanced equation. Moles on the bottom, moles are what I'm trying to find on top. These are my coefficients for my balanced equation. And then I'm going to switch this back to grams. Again, 1 mole, and this is its formula mass. And then you just multiply and divide. Okay? Okay, here's another one. How many moles of carbon dioxide are produced by 18 moles of C2H6? Again, got to have that balanced equation. No balanced equation, can't do the problems. Okay. So that's not a very good underline, but if you're doing moles to moles, moles is really easy, you guys. It's just 1 step. Write down what you know, 18 moles of C2H6. Put that on the bottom. I'm trying to find carbon dioxide, put that on the top. Then I look at my balanced equation, 4 here, 2 there. Voila, I'm done. All I have to do is take 18 times 4, divide by 2, and I get 36 moles. So when I start with 18 moles of C2H6, that's ethane, I'm going to produce 36 moles of carbon dioxide. Okay. How many grams of water are produced from 5.4 moles of carbon dioxide? Okay, now I'm going from grams. I'm starting with moles, but I'm going to grams, so I have to add 1 step. Okay. Again, write down what you know. I know that I have 5.4 moles of carbon dioxide, so I write that down. Well, if you're in moles, you guys don't change it to grams. If you're in moles, you say yay, because it's 1 less step you have to do. Okay, if it's in grams, you have to change it to moles. But if it's in moles, just go to your mole ratio. Okay, so I put moles on the bottom of CO2, and moles are what I'm trying to find. It says how many grams of water, so I put that on top. Then I go to my balanced equation. Well, there's a 6 in front of water. There's a 4 in front of CO2. Put those numbers in. Then I multiply. Now, the question says how many grams of water. Up here I got to quit and moles because that's all it wanted was moles. But now I got to do 1 more step. 1 mole of water has a mass of 18 grams. That's like we did before. This is just a conversion. Okay, so I take 5.4 times 6 times 18 and I divide by 4 and I get 145.8 grams of water. So when I'm looking at this, when I have 5.4 moles of this, I also have 145.8 grams of this. Okay, so you can do mole to mole, which is 1 step. You can do mole to mass or mass to mole, which is 2 steps, or mass to mass. And I think I have 1 more mass to mass problem. Yeah. Okay, so here we have an equation and it's balanced. That's important. How much oxygen is needed to produce 56.8 grams of ammonia? This is ammonia. And it should probably say how many grams. Anytime this is how much. Grams is the most common because that's what we can measure. Okay, so I probably should have put that in there, but bear with me, okay? All right, so again, start with what I know. 56.8 grams of ammonia. I got to get rid of grams and change it to moles. So 1 mole ammonia, 17 is 1 nitrogen and 3 hydrogen added together. So now I got rid of grams of ammonia and I got moles. Now I do my mole ratio. Moles are what I'm trying to get rid of on the bottom. Moles are what I'm trying to find on top. I'm trying to get rid of ammonia. I'm trying to find oxygen. Okay? All right. So then what I do is this, the 5 and the 4 came from my balanced equation. 5 here, 4 here. And now I got to change oxygen into grams. So 1 mole, and it's 32, not 16, because it's O2. So there's 2 oxygens. 16 plus 16 is 32. So I take 56.8 times 5 times 32, divide by 17, divide by 4, and I get 133.65 grams of oxygen. Okay, that's how many I need to make, if I'm reacting ammonia and oxygen together, for every 56.8 grams of ammonia, I need 133.65 grams of oxygen. If I don't have that, then I'm not going to get my full product. Okay, I can add more ammonia, but if I don't have enough oxygen, it's not going to matter. I'm just wasting it. So that's how they use stoichiometry. They make sure they have the right amount of reactants to produce the product that you want. Okay, if you don't have enough of something, you need to add more of the right thing. If I don't have enough oxygen and I add more ammonia, I'm just wasting it. So it's really important. And usually with these reactions, they want to make sure that if you're going to have something left over, it's going to be the cheap stuff. Okay, you don't want to waste the expensive stuff, because in business it's all about the Benjamins, right? So that's important to look at too. So you can figure it out on paper really what you need and how to go about your reaction. I think that's it. Yep. So this is it for the notes today. Work on these problems. They just take a little practice. It's everything we've done. It's just putting it all together. And to me, it's where it kind of starts to make a little sense. So work on your stoichiometry problems. And we have one more part, and then we're done with this chapter.